Hey, this is Amos, the math guy, Amos, the STEM guy. Did you know you could finish Algebra 1, Algebra 2, and Pre-Calculus all in 1 year? That's three courses of math, which also come with the ability to get college credit for college algebra and pre-calculus. I provide those resources to families. As a matter of fact, if you want to get intermediate algebra credit, we can do that as well, which would be your algebra 1 for this. So basically, imagine you can get college credit for all these and you finish all these in 1 year without any problems at all. Before I show you how these are connected and how the American education system honestly is like a game and how you can be more efficient in going through it rather than allowing it to slow you down towards your goals. Here's a couple of books that will explain this better. This is called Rethinking Math Learning. Basically teach your kids 1 year of math in 3 months. That's interesting because that's kind of what we're going to do with this curriculum. This book is called Peak, How All of Us Can Achieve Extraordinary Things. This is the guy who did the 10,000 hour research that you might have heard about people becoming masters after 10,000 hours. And then this is a book I wrote called Tools for Mastery Mathematics. If you email amosthestemguy@gmail.com, I'll send you a copy. But in this book, I tell you how to become good at math, what is mathematics and how do you excel at it. And then I actually give you a reference book that shows you divisibility rules, integer arithmetic, place value, things like that. I actually have that right here. All the different things that are in the reference guide section available to you. And then in the third part of the book, what I did is I listed every single math topic that kids learn from kindergarten to calculus. No matter what country you live in, no matter where you are, no matter what time in history you live, these topics are constant for becoming good at math and in calculus. And then in the last section of the book, I actually provide you with a list of top mathematicians that the world has ever known. I have some mathematicians out there. You might be here. My wife and I are blessed with 7 children. This is the list of mathematicians, some of the people, mathematicians, scientists, astronomers that gave us what we have in science and math today. Okay, so that's that. And then lastly, I'll talk about this again at the end. This is the book you need to learn math from the beginning to the end, from the greatest mathematician, Leonard Euler. So this book is part of my curriculum, Elements of Algebra. I have a video playlist that goes over more of Euler's work. Euler basically starts from basic math and he works his way all the way to advanced mathematics. Okay, let's begin with Algebra 1. Now, you don't need to memorize everything I say here, but I just want you to notice the challenge with American math education. Okay, just notice this, and then also remember that people take 3 months off for between grade levels. So like this summer, June, July, and August, some people are going to be doing no math formally. They're just going to be doing whatever they want to do. And here's the problem: is they're going to lose some ground. So then in the fall, a lot of curriculums will try to teach knowing that the students have lost ground. What if we didn't do it that way? What if our students instead were given the opportunity to do more math in the summer? What are your thoughts on that, right? When students finish these 3 courses, they should be able to take the CLEP calculus exam and excel at it. They should take the calculus preparation piece, which we have from our program, and then they should be able to take calculus credit. Why does Amos want people to get to calculus with efficiency? So they do calculus 2, calculus 3, linear algebra, differential equations, discrete math, elementary statistics, if engineering or math or medicine is in their path, right? Now, medicine doesn't require some of those other courses, but math is beautiful. Why not just do as much of it as you can before you graduate high school? Okay, so this is chapter 1 from the Algebra 1 book. Expressions, equations, and functions. No problem there. We're working on equations. Love it. Properties of real numbers, which I cover in my book as well, but they need to learn properties of real numbers, how to add, subtract, multiply, and divide real numbers. Okay, no problem. Then we need to learn how to solve linear equations, 1-step equations, 2-step equations, multi-step equations, ratios and proportions. Now, keep in mind that this is taught in some pre-algebra books, but let's forget about the repetition for now. Let's just say, okay, no problem. We're going to learn it again well here. Graphing linear equations and functions, no problem. Let's graph our lines. Writing linear equations. This is excellent to learn your slope-intercept form and parallel and perpendicular lines. No problem at all. Solving and graphing linear inequalities. That's excellent. And then we move on. We move on to systems of equations and inequalities. Great. Exponents and exponential functions. Polynomials and factoring. This is one of the most important topics, by the way, because without this, you can't do much of anything else in Algebra 2 and Pre-Calc. polynomials and factoring, quadratic equations and functions, radicals and geometry connections. Pythagoras theorem is taught here. Okay, no problem. Notice in my series, I didn't talk about geometry at all, but notice we do some geometry along the way. Even the coordinate geometry that happened earlier. By the way, that came from René Descartes. The French mathematician gave us some of that foundation. Rational equations and functions, probability and data analysis. Now, there's a class called statistics, so honestly, we can just put that in that class and expect everybody to take statistics. That's an important class. Okay, so that is Algebra 1. What about Algebra 2? What does Algebra 2 look like? Okay, so I just picked some good textbooks that I could find, general textbooks that many schools in the country are using. What's the very first topic? Solving equations and inequalities. Let's go back to the Algebra 1 book. Didn't we solve equations and inequalities earlier on in chapter 3 in Algebra 1? We did. Okay, so when we get to a topic like this in the fall, for a student who really loves math and who was doing math in the summer, they shouldn't have to do chapter 1 because they actually know how to solve equations and inequalities. Number 2, linear relations and functions. Notice that we're learning slope. We're learning slope from the beginning, not like we're learning it in a different way. No, from the beginning. So, but we learned slope in Algebra 1 though. If we were paying attention in class, we learned slope and the slope-intercept form in Algebra 1. Systems of equations and inequalities. We graphed systems of equations and inequality. We did that in chapter 7 of Algebra 1 though. So chapters 1, 2, and 3 are just review. Chapter 4, matrices. Okay, that's new. We didn't cover that as much we didn't cover that in the first book. No problem. So that's new. No problem. Let's do that. Okay. Chapter 5 is polynomial and radical equations and inequalities. But we did work with polynomials and factoring in Algebra 1, right? Okay. So again, we can go through that pretty quick. Quadratic functions and inequalities, but that's chapter 10 of our Algebra 1 book. So if we did Algebra 1 well, we shouldn't really be doing that. Polynomial functions, that is new at this level. It is new. So we have chapter 4 and 7 are new. Chapter 8 is new, conic sections, no problem. Chapter 9, rational expressions and equations. That's fairly new, but we actually covered some of that in the other book as well. So no problem there. Okay, we can cover that again if we need to. Because if you remember in chapter 12 of Algebra 1, we did add and subtract rational expressions, multiply and divide rational expressions. Chapter 10 is exponential and logarithmic function relations. No problem. We can do that in more detail here, even though we touched it in Algebra 1. Sequences and series. This isn't discrete mathematics. We teach that as a full course for college credit, but you can do it here, no problem. Chapter 12 is probability and statistics, but that was part of what I said in the other book, probability and data analysis, is that we have some probability data analysis that is taught in statistics, and we have it here as well. We can do that in statistics as a course. Then we have trigonometric functions and trigonometric graphs and identities. These two topics are actually taught in pre-calc. So that means in Algebra 2, we have about 4 or 5 topics that were in Algebra 1. We have about 1 or 2 topics that are taught in discrete math and statistics. And then we have 2 topics that are taught in pre-calc. So that means Algebra 2, actually, half of it is literally just either review or doing things that somebody will encounter again. Okay, before we so I just want to show you, this is part of why I do what I do, is equip families with tools to be more efficient, to help the kids figure out more about what they want to do with their lives, rather than doing homework over and over again on concepts that some of them have mastered. Let's go ahead and look at pre-calculus together. This is pre-calc. Okay, the first chapter is on set of real numbers, absolute value, and so on. Polynomials, factoring, quadratic equations. So this is a lot of review. We know that already. And we did that in Algebra 1 and 2. But so imagine you coming into pre-calc, that's a lot of review. Chapter 2 of pre-calc is coordinates, graphs, and inequalities. We did all of this in Algebra 1 and 2 already. Chapter 3 is functions, the definition of functions, inverse functions, and so on. It will go into more detail in pre-calc. That's fair. Let's start from chapter 3 then. So we've reviewed all of these already. We don't really need to be doing all the homework here if we've been doing math regularly. So you have functions, and then polynomial and rational functions. Some of that was in Algebra 2 already. And then we have exponential and logarithmic functions. That was in Algebra 2 also. So I'll go back to that section. This is in Algebra 2, logarithmic functions and relations. trigonometric functions of angles, trigonometric functions of real numbers, and then it goes into trig identities. Okay, but right at the end here, we did trigonometric functions and trigonometric graphs and identities in Algebra 2. So this section here, a lot of it is already covered in our Algebra 2 book, right? Then we have systems of equations and matrices, but we did that in Algebra 2. Analytic geometry, we did that in conic sections. Roots of polynomial equations, we did some of that in Algebra 2. Sequences and series, we did that in Algebra 2. Okay, so my question then is, if a student is serious about math learning, wouldn't it make sense then to condense all of these without duplication into one book that that student can use so that they can master the principles with efficiency and get moving to the next things in life, rather than burning them out with doing system of equations problems for 3 years in a row when they can do it one year and do it well? What do you think? I personally think the American math curriculum is broken and we can help more children learn with efficiency, which brings me to Leonard Oer's book. If you want to be a basketball player, if you want to be the best in basketball, it makes sense to learn from the best. If you want to be the best in math, maybe you should learn from the best. Leonard Oer published 50 papers a year as a blind mathematician. He went blind later in life, faced a lot of adversity, and he still transformed the world of mathematics as we know it. Let's look at the table of contents of his book. So in his book, it starts out by talking a little bit about his biography, which is just so cool to read. So our students will learn a lot about Leonard Oer's life. Now we go over to, this is in the 1700s, right? This is about 1750. He talks about what math is. He talks about addition and subtraction, multiplication. He talks about division. Isn't that cool? He starts from the basics of fractions, properties of fractions, addition and subtraction of fractions, multiplication and division of fractions. Notice that he's talking about the fundamentals of some of the pre-algebra. He does get into logarithmic tables. Logarithms come from John Napier, by the way, amateur mathematician. And that's what he's called. It's just cool to learn about these guys were ordinary people changing the world in math. And then, yeah, he goes into of the different methods of calculating compound quantities. So that's the second part. So I love how Euler is building his case step by step. He's going to talk about ratios and proportions. He's going to talk about algebraic equations and the resolution of those equations. He's going to talk about containing the analysis of indeterminate quantities. And then he's going to go on and talk about just so many cool things relating to algebra. This is one book from the best that we can learn from. We can learn alongside these other books, but honestly, let's make sure that we're not wasting time, but instead helping students be who they were created to be. Please subscribe for more videos like this, where we talk about math policy, STEM excellence, vision, career planning, college prep, and just helping every child be who they were created to be. Thank you for watching. Take care and God bless.